In this lecture, we look at the simplest of polynomials, the linear functions. A line joining 2 points P with coordinates x1, y1 and Q with coordinates x2, y2 has slope m equal to the change in y over the change in x, that is, y2 minus y1 divided by x2 minus x1. In the geometry of the Cartesian plane, any 2 points will determine a unique line. So this equation, the slope, is a natural and important property of a line. If a line joins 2 distinct points, P and Q, in which the x-coordinates are the same, then the line is a vertical line of the form x equals x naught, and we say that the slope is infinite or undefined. In this case, the change in x, the denominator, is 0, so we say the slope is infinite. Given 2 points, P and Q, on a line, the difference of the y values, written delta y defined to be y2 minus y1, is the rise between the points P and Q. And the difference of x values, written delta x is defined to be equal to x2 minus x1, is called the run. Thus the slope of a line is delta y divided by delta x. It's the ratio of the rise to the run. The slope of a line identifies how quickly a line rises or falls. In other words, it describes the number of units one rises as one moves 1 unit to the right. Take 1 step to the right, how far up do you go? That's the slope. For example, if a line has slope m equals 4 and goes through the point P with coordinates 10, 100, then when x is 10, y is 100. So when x is 10 plus 1, that is 11, y will rise by 4 to 104. If we increase x by 1 from 11 to 12, y will rise by 4 to 108, and so on. If we increase x to 13, y rises by 4 to 112. If x is 14, y is 116. Every time we move to the right one, or increase x by 1, we increase y by 4. That's what the slope means. Suppose we have a point P on a line of slope m. Then given any other arbitrary point Q, x, y, on the line, we can still write out the equation for the slope. It's the change in y values over the change in x values. The point Q is arbitrary, x and y are unknown. The point P is known, x1 and y1 we supposedly know, but we have this nice equation for the slope, and if we solve for y in this equation, we will get that y is equal to m times x minus x1 plus y1. Either of these two equations, equation 2 or 3, will be called the point-slope form for a line because they're created out of a single point and the slope. This is in fact the most important equation for a line, the point-slope form. Another equation for a line has form ax plus by equals c, where a, b, and c are constants associated with the line. This form is called symmetric because it does not attempt to single out a special variable like y. It expresses the equation in terms of no special variable. A favorite form for many students for the equation of a line is the slope-intercept form. This is the second most important form, not the first. We began by discussing linear equations that y equals a1x plus a0. These are degree 1. X is multiplied by something. It's easy to see, isn't it, that a1 represents the slope of this line. If I increase x by 1, what happens to y? If you increase x by 1, then a1x will increase by a1. So if you increase x by 1, y increases by a1. That's the slope. So here a1 is the slope. The value a0, the constant term in this equation, represents the y-intercept since it is the value of y when x is 0. The constants a1 and a0 are more popularly replaced by the letters m and b. So we often speak of the equation y equals mx plus b as the slope-intercept form for a line. An interesting question is why we use m for slope and b for y-intercept. Let's do some exercises. Let's find the equation for the line of slope 4 passing through the point 620. Let's put our answer in point-slope form, the most important form for a line. Let's put our answers in slope-intercept form, and put our final answers in symmetric form. In point slope form, we first write out the formula for slope using the 2 points and an arbitrary point xy. Let's use xy and the point 620. That's the only point given to us. So our answer begins with the slope 4 is the difference in y values, y minus 20 over x minus 6. We have an arbitrary point xy and a known point 620. We write out the slope using that information. If we clear denominators, we get 4 times the quantity x minus 6 is y minus 20. There's the point slope form. On the other hand, we could do the slope-intercept form. We know the slope is 4, so y will be equal to 4x plus b. That's a line of slope 4. Now 620 is on the line, so we can plug in 6 for x and 20 for y and discover that b is minus 4, and therefore y is 4x minus 4. There is the slope-intercept form. To create the symmetric form for our line, start with any of these previous equations. I'll start with the first one. And then use algebra to put all the variables on the left. If I multiply the 4 through, I get 4x minus 24 is y minus 20. If I subtract y from both sides and then add 24 to both sides, I get 4x minus y is 4. Our variables are on the left, the constants on the right. There is the symmetric form. In the next presentation, we'll continue to look at slopes of lines and introduce the average rate of change of a function.